Okay, so now I'm going to go through question 5 of that June 18 paper. So it says, given that 3 sine theta plus 2 sine theta plus 2 cos squared theta is equal to y, show that dy by d theta is equal to a over 1 plus sine 2 theta, where we need to find what a is. So firstly, we are going to need to differentiate that, and we are going to have to use the quotient rule to do that. So let me get my 3 sine. Oh, that did not write the way I wanted it to. Let's try that again. So 3 sine theta over 2 sine theta plus 2 cos theta. So let's just define what our parameters are. So f of x here would be 3 sine theta. So for quotient rule, f of x has to be the top one. What was that? That was meant to be sine theta. I don't know what I wrote, but it wasn't sine theta. And then the first derivative of that, I don't know why I was writing g of x there. The first derivative of that will just become 3 cos theta, because sine differentiates positive cos. And then our g of x is our 2 sine theta plus 2 cos theta. And then the derivative of that is going to be 2 cos theta minus 2 sine theta. Okay, so we got that. So now we can use our quotient rule to find what dy by dx is. So dy by dx will be equal to, so it's going to be g of x times by f dash x. So that will become, I'm going to write it as a 6, because when I do that 3 times 2, it's going to make 6. So 6 cos theta sine theta plus cos theta. And then that will be minus, because we're using quotient rule. And then it's f of x times by the derivative of g of x. So that will become, sorry, I've not got enough space to fit all on one line. So that will become, again, I'm going to make it 6 again, because I can see that 3 times 2 is going to make 6. So 6 sine theta, and then that will be, I've still not given myself enough room there. 2 cos theta minus 2 sine theta. 2 cos theta minus, oh no, I don't need the 2's, do I? So it'll just be cos theta minus sine theta. And then that will all be over g of x squared, which would be 2 sine theta plus 2 cos theta. I'm going to zoom out again to make sure I can fit it all on. So that will all be over 2 sine theta plus 2 cos theta, all squared. So this thing here is differentiated, but obviously it doesn't look like the form we want it to look like. So what I would do is I would first of all sort out the top bit, because to me, I can see the bottom bit I'm going to have to do some manipulation with, but the top bit, if we expand it out, things might happen and things might cancel out and it might look a little bit nicer. So let's do that. So I'm going to end up with 6, try that again, 6 cos theta sine theta plus 6 cos squared theta minus 6 sine theta cos theta minus 6, I'm still running out of space, minus 6 sine squared theta. And again, that's all still over that 2 sine theta plus 2 cos theta all squared. So now let's have a look at what we've got here. So I have a 6 cos theta sine theta, and I have a minus 6 cos theta sine theta. So those things there are going to cancel out. And that's why I'm just going to zoom in, because I think it's a bit easier to look at when it's a bit zoomed in, given that I can fit it all on one line. So that will leave me with 6 cos squared theta plus 6 sine squared theta. Is it plus, isn't it? Why have I put minus? Oh, minus would become a plus. There we go. It's a plus now. Minus minus to become a plus. And that would all be over again, that 2 sine theta plus 2 cos theta all squared. And I'm hoping we can recognise that if you factorise the 6 out of there, it becomes 6. And then it becomes 6 sine squared theta plus cos squared theta. So it becomes 6 sine squared. Where's the n gone? There we go. Sine squared theta plus cos squared theta, which would just become 6, wouldn't it? So this thing here is just equal to 1. So I'm just going to cross that out. So it's just 6 over that 2 sine theta plus cos theta, 2 cos theta even, all squared. So I think the top bit we dealt with quite nicely. So let's think about this bottom bit. So I think, first of all, I would like to expand that out because I think that's going to help me, because the form it's in at the minute isn't the most helpful to us. So I think I'd like to expand that out. So let's do that. So 2 sine theta plus 2 cos theta, and then 2 sine theta. And you might be able to spot something here that I haven't, which is fine, because sometimes there's multiple ways of getting to my answer, but if you can't see something and it's brackets and things, expand them out, see what happens. So that's going to give me 4 sine squared theta here. End up with a 2 sine theta cos theta and another, a 4 sine theta cos theta, another 4 sine theta cos theta. So I think that's going to leave me with 8 of those in total. 8 sine theta cos theta. And then that would give me a plus 4 cos squared theta. So again, let's just tidy that up. So I end up with, I think, 4 sine squared theta plus cos squared theta plus 8 sine theta cos theta. And again, hopefully I'm recognising that that thing is just 1. So get rid of that. So I end up now with the denominator being this. So I am thinking that's starting to look a bit more like what I want it to, I think. Because I know I've got 4 and 8, but I've got a number and then a trig term. So then I'm looking at this sine theta cos theta. I need to think about where I've seen that before. And I'm hoping we're thinking double angle formulas. We should have seen that before. So if I think about, if I was to do sine of 2x, yeah, or I guess I should call it theta. We'll call it theta for consistency. So again, you remember, you get this from just using the addition angle formula and replacing a and b with the same parameter. But that will get you 2, if I can use the pen correctly, that will get you 2 sine theta cos theta. So we have 8 of those. So if we multiply both of these by 4, it would come to 8 sine theta cos theta would come to 4 sine 2 theta. So I can now rewrite that as, oh, I don't know what I did there. I really don't know what I did there. No, that's a rubber. Try again. 4 plus 4, there we go, sine theta cos theta. So the denominator I can now replace with this, which I'm quite liking the look of, because I'm thinking I can factorise. Oh no, hang on. Sorry. If I did the right thing here, it should be sine of 2 theta. There we go. Sorry if that, nope, not squared, a 2. Sine of 2 theta, sorry. Yeah, because that's the whole point of doing that, is we were trying to replace it. So yes, I end up with that, which is good, because if I factorise the 4 out, that's 1 plus sine 2 theta, isn't it? So that's quite promising. So let's just remember what we had, because I know I've been working on the denominator for quite a while now. We might have forgotten what happened to the numerator. But the numerator, I believe, if I go back at my working, became 6. Let's check. Yeah, it just became 6, didn't it? So my working here would be 6, and I'm just going to factorise that 4 out to make it 1 plus sine of 2 theta. And what that means then is that A, if I bring that 4 up there, it's not the nicest number in the world, but it would be 6 over 4, 1 plus sine of 2 theta, which 3 over 2. So A would be 3 over 2 or 1.5. A would be 3 over 2 or 1.5. So that would be your answer for question number 5. So I think the differentiation would be fine. It's just about being able to rearrange trig, and when we're looking at year 13, it's thinking about where could the double angle formula potentially be used, especially if we're seeing a sine 2 theta.